answers are on there. We're looking at Green Book, page 308 here, section 6.4, which corresponds to our section 5.4. And the answers are, most of them are on your sheet, I believe, but bottom line is number 65 should have gotten true. 66 is false. 67 is D. 68 is D. 69 is E. And 70 is E. Okay, so questions are 60 what? Alright, so on 67 we have this f function. It's defined as from a to x of ln of 2 plus sine t dt, and it says that our f of 3 is equal to 4, and we want to find f of 5. So now keep in mind with this function, if we want to find values of f here, if we could actually find a function for f, that would be nice. Okay, but for our purposes here, the derivative of this is going to be something that's virtually impossible for us at this point. So remember the other part that we talked about when we talked about the fundamental theorem was that if we want to have an antiderivative for some integrand like that, that we could write it as just an area function and not actually calculate the integral, but just leave it as an integral function. So remember what the issue was, though, is that I need to match this up with what the initial condition here. And they told us that the value of f at 3 is 4. So remember what that entailed was is that we'll make this a value of 3, because ultimately if I were to now put a 3 into this, I'd get what for this whole thing? If I put a 3 here right now, what would I get for this whole integral? I'd get 0. But I want the answer to be what? 4. Okay, so keep in mind that, and if you need to write it in parentheses, feel free to do that. But bottom line is that whole expression right there, if I were to put a 3 into it, okay, that would give me 4. So if I write this as my actual function here, so that now I can find other values with it, okay, that would be my f of x function. Okay, so again, I'm going to put 3 in for a, and then I'm going to put a plus 4 on the end because, like I said, if I want to put I need this to be a fact. I need that to be true. Fair enough? And with this, putting a 3 here and a 4 here, make that true? Yeah. If I put a 3 in here, I'd put a 3 here. The integral would be 0. I'd get 0 plus 4. I'd get 4. So now, again, this is my function I'm going to work with. And so if at this point, for number 67, they want to know what's f of 5. And ultimately, I'd need to find the area from 3 to 5 of ln of 2 plus sine t dt plus 4. And so from there, it's a calculator problem, because we can't find the antiderivative for that. So we'd have to use our integral command on the calculator. And if we do so, we should wind up with 4.555. Correct. So and that's the whole purpose of wisely choosing a 3 here, because we know that if we put a 3 into it, we want this to be gone, and then we can just add a 4 on the end, and that makes 3, 4 for us. Yep. So whatever that point is that we know about, okay, we make the lower limit, whatever the x value is, and we make the plus on the outside, or the minus if it was negative, we put that on the outside of the integral. That way when we put a 3 in there, we get no area here, plus 4, that gives us 3 in, 4 out. What else on that page? On 70, we have the area of the region enclosed by the graph of y equals 1, radical 1 minus x to the 4th, and the x-axis is the following. So ultimately our integrand here, if you will, is this. We could certainly draw a picture of that if we wanted to. With the area, though, between it and the x-axis here, keep in mind that if we were to put plot a couple points here, I guess, let's say, if we put a 0 in here, we're going to get 1, so 0, 1 we know is a point. If we were to put a 1 in here, we get 0, so 1, 0 is a point. And if we put a negative 1 in there, we're going to get 0 also. So really this is very much like a half circle then, isn't it? Okay. And we can see that it's above the x-axis between negative 1 and 1, so our answer then would be just negative 1 to 1 of the square root of 1 minus x to the 4th dx. Issue is here, do we need to find an antiderivative and use the fundamental theorem to calculate this area? No. Alright. Yeah, and keep in mind that we ultimately, this is the end of the function. There is no more to it, because ultimately if I put anything bigger than 1 in here, it's going to be a negative under the radical. Anything smaller than negative 1, same deal. So that is the picture. So with that, we could try to use the fundamental theorem here, but we're going to have a hard time finding an antiderivative for that. And bottom line, since it's multiple choice and you look at the choices on there, are those algebra answers or are they calculator answers? Calculator. So apparently, if you plug that in, it should be approximately 1.748, which is letter E. What else from page 308?
So should we waste any time doing that, or should we just enter it in the calculator on the AP, if it was calculated?
If you're in the calculator portion and you have a definite integral, if you waste 1 second on doing any algebra, then you're wasting time. If it's a definite integral, you're allowed to just write the integral down. Like on the free response, they would want to see the integral and the answer. If you wasted a bunch of time doing the fundamental theorem with this and you're in the calculator part, okay, then you're doing exactly that. You're wasting time. So, all you need to do is write the definite integral and then calculate it with calculator. If you're in the non-calculator part, obviously that's not going to work, but they also wouldn't give you one that's not integrable either. Say that 3 times fast.
Integral. Yes, they want.
All right. What else? 308. 68, it says, what is the limit? As h approaches 0 of 1 over h, we have x, and we have x plus h of f of t dt. Alright, so bottom line is, if we were to try to directly evaluate this, we would find that putting an h in there, and putting a 0 in for h, ultimately the 1 over 0 part would give us something undefined immediately. True? Okay. Alright, so the question is there anything else that we can do with this then to come up with an answer in terms of finding this limit? Is there any other way we can put our h in there, or 0 in there if you will, and come up with an answer? Well, keep in mind that if h approaches 0 here, okay, in the area part here, what is this going to be? If we put a 0 in here, in this part, then ultimately aren't we going to go from x to x of f of t dt? So ultimately, what is that going to equal? And isn't that just 0? So no matter what this value is, the answer is going to be what? It's going to be 0, isn't it? Okay. Alright. Now, the issue that we have, though, is that when we do that, keeping in mind that that this being 0, this is not 0, however, and it's really not a number. If I put 1 over 0, keep in mind as I approach 0, if you will, okay, this function we know looks like this essentially, true. And so, isn't really the answer to that infinity? True. So, question is 0 times infinity? Is it 0? And what it boils down to is the answer is it's actually what we call an indeterminate form. Okay, and just for time's sake at this point, since this is an indeterminate form, you'll notice the answer is not 0 as I read it, right? Okay, it's d, it's f of x. What I want you to do is just kind of, we'll stash that away for the time being. This is not going to be anything we're responsible for on this, and it's not really an AV problem. It's kind of thrown in there. And I don't really want to go through the indeterminate form part of it right now. Okay. So we'll just leave it alone for the time being. But bottom line is, this part would be 0. That's one thing that we should be able to recognize here. The fact that if we put an h equals 0 in there, we would get from x to x, which would give us 0. Okay. But in terms of handling this indeterminate form part, you're not going to be responsible for that, for this AV part. And so we'll just leave it alone for the time being. Okay. We may revisit that later on in this class, but we'll leave it for the time being. Alright. What else?
69.
And 69, we have yeah, 69 is a no, because we didn't do a linearization part. Was that in this section?
38,
Did we, oh, I know. Yeah, we didn't do linearizations, because we didn't do that. It's actually part of our, I think it was part of the previous chapter. So, you can go ahead and skip 69 also. Alright, let's move on to the next part here, which we had was page 318. On page 318, we had, I think all the answers are on there too. Should be 31 false, 32 false, 33A, 34 is D, 35 is C, 36 is C. So, about one from that group. We have for a given value of n, trapezoidal rule with n subdivisions will always give a more accurate estimate of the actual area than the right Riemann sum with n subdivisions. The answer here, normally that is true, but the question is it always true? If we have the example they gave is that the two approximations would be the same if we had a constant function. And think about that if I had if I just had y equals 3, for instance, on 0 to 3. If I did a right Riemann sum, I would have right endpoint over, right endpoint over. I would actually get the true area, wouldn't I? If I made rectangles out of this. And if I made trapezoids out of this, if I went from here to here and I connected them, wouldn't my trapezoid actually be a rectangle in this case? But wouldn't they be exactly the same? So again, the question is to say that the trapezoid rule is always more accurate than the right Riemann sum. Is that an accurate statement? No. Almost always. But in the case of constant function, they'd be the same. What else? 32 to 30, 31 to 36. Buddy?
35.
And 35, this is the trapezoidal approximation for the sin x function for equal subdivisions on 0 to pi. Keep in mind that our h over 2 part, our h, the subinterval length here is pi, or the whole interval length, I should say, is pi. The subintervals, there's 4 of them, so if we divide pi into fourths, we'd have pi over 4 would be the length of each. And if I have pi over 4 over 2, then I'd have pi over 8 as my outside part. So I should have a pi over 8 there. And then I should have my x's that I'm going to use here are going to be 0, pi over 4, pi over 2, 3 pi over 4, and pi over 2, or pi I should say. So ultimately my my value here, sin x, if I put 0 in there, I'm going to get 0. And then I'm going to have 2 times. And now I'm going to put pi over 4 in there. Pi over 4, sine is going to be radical 2 over 2. And then I'm going to put pi over 2 in there. Sine of pi over 2 is 1. And then I'm going to put 3 pi over 4 in there. Sine of 3 pi over 4 is back to radical 2 over 2. And then I'm going to put sine of pi in there. Sine of pi we're back to 0. So with all that said, we're going to have 2's cancel on both of these. This is going to be 2, so we'd have 2 plus 2 radical 2, if we add that up, times pi over 8. And you notice that the choices that they left you there were, they look similar to this, at least C, D, and E do. They're not exactly the same. We don't see any that have 2 plus radical 2. We see some that have 1's here. In fact, if we were to factor out the 2, if you will, we'd have 1 plus radical 2, and ultimately what would happen with the pi over 8 and the 2? Would make pi over 4, and so therefore we'd have that one. Should correspond to the correct answer, which is C. Alright, what else? Page 318. How about the quick quiz problems on 319? Looks like the answers are on there. 1 is C, 2 is D, 3 is C, and 4 is free response. I'll show you the free response answer here. Check yours. Here's your quick quiz answers here, number 4. Ronnie, were we right?
Yeah. Yep.
0.744.
0.7.
I wonder why that's off. This is set up to have 2 over 8, so 1/4 out in front. Sign should add 0 and then 0.5.
I think I just round it.
Yeah, make sure when you do this part in here, if you have to put numbers that are not nice values of x here for sign, make sure that you do all that in one calculator sequence so that you don't have any rounding errors. So as soon as you start rounding stuff and then typing it back in, it's going to give you rounding errors, which is on the AP test not okay. Like if you got 740 on this, or so it's supposed to be 744, okay, you'd lose the answer point. It'd be wrong. Okay, even if you had all that right, you'd get points for the setup on the pre-response, but if your answer was wrong, okay, it'd be wrong.
Plug it in all at once.
Okay. Yeah, I'd type all that in at once if I were you. And ultimately, it should be increasing on 0 to radical pi. That was your 1.7 something or whatever, I know, wasn't it?
Yeah.
And ultimately, did you? I mean, keep in mind it's periodic. Does it tell you to go to a certain place? It's from 0 to 3, right? There should be another section where that becomes greater than 0 if you graph it from 0 to 3. Should be two spots where it's greater than 0. Yeah, then you'd have missed that other one then. So, yeah, if you go from 0 to 3, you should see 2 places where that's greater. And then the last part they ask us for the average rate of change. And ultimately we know the average rate of change is the integral times 1 over the length of the interval. And ultimately they told us that the average value equaled k. And so they want to know what's the relationship between this integral and k. Well, ultimately if we want to get that integral alone, we just multiply by 3. So what does that integral equal? 3k. Alright, I think that's all the problems that we were working on for yesterday, I believe.